Hello and welcome into the example video for lesson 12 for Precalculus 2. This will be all of our different types, not all of them, but many types of our trig equations. So I'm just going to kind of put here, find the solutions. Whoops. How about if I share the document camera first? That would help. All right, so let's try this again. So find the solutions to the given equations on the interval 0 to 2 pi. So again, you see 0 has the bracket, so 0 could be in our answer. If we get something that could be 2 pi, we don't include it because that's got the parenthesis. So we're only talking about one time around the unit circle and stopping. That's it. So we're not, if this had said find all the solutions, like I mentioned in the content video, you're going to put plus 2 pi k at the end of it. But in this case, just to keep it a little simpler for us, we're just talking on the interval 0 to 2 pi. So the first one we have, let's start out crawling, right? Like a baby does. Sine of theta is a half. So this is similar to what we had in the content video. There's no work for us to do. We don't need to factor it. We don't need to really do substitution or anything. This is already almost at the final stage. And this is asking what? Our question says, where on the unit circle is sine equal to positive half? So if I pull out my entire unit circle and look at it, it's what? It's when theta is pi over 6 and theta is 5 pi over 6. That's it. Right? That's all we have to do there. Second example, let's say we have tangent squared of theta minus 1 is 0. So let's do substitution. Again, for a lot of people, that seems to make things clearer. So I'm going to say, okay, let x equal tangent of theta. That's the substitution I'm making. So tangent squared minus 1 means that this thing is really x squared minus 1 is 0. So I do what? I add 1 to both sides. I get x squared is 1. And now to solve this, I do what? I take square root, but what do we have to be careful of when I have a simple quadratic that's not so simple because everybody always messes it up? I have to say what? X is equal to plus or minus the square root of 1, which is 1. And now I'm not done because I didn't start with x. I put the x in. So put our tangent back. So this really means tangent of theta is plus or minus 1. Let's solve this one without the substitution. It's still going to be the same steps. Add 1 to both sides. So tangent squared theta is 1. Take the square root of both sides. So tangent of theta is plus or minus square root of 1, which is 1. So you see, we end up at the same spot. It's just one, we're only working with x's, which, again, for some of you, makes these a lot easier. You see that tangent, it's like, yep, that's it, I'm done, I'm out. No idea what to do here. But if I put in x equation, now it's like, oh yeah, I've been doing these for like the last 10 years of my life, no problem. So we have what? Tangent of theta is plus 1, and tangent of theta is negative 1. So let's look at these separately. First of all, where on the entire unit circle, because that's what this is asking us, on the interval 0 to 2 pi, so where on the entire unit circle is tangent positive 1? Well, that's pi over 4 and 5 pi over 4. And then this one, where's tangent equal to negative 1? Well, that's 3 pi over 4 and 7 pi over 4. So that would be my answer for that equation. All right, third problem. Let's say we have cosecant squared theta minus 2 is equal to 0. Oh boy, cosecant and it's squared. What am I going to do here? Well, you can always substitute. You can say let x equal cosecant of theta. So I can rewrite this as x squared minus 2 is 0. So x, if I add both sides, is x squared is 2. And now take the square root. So x is plus or minus square root of 2. But I didn't start with x, I started with what? Cosecant. So cosecant of theta is plus or minus root 2, which will get the same thing over here. Add 2 to both sides. Cosecant squared of theta is 2. Take the square root. So I get cosecant of theta is plus or minus square root of 2. Now, here's the issue for us. I know sine, cosine, and tangent on the unit circle, but I have no idea of my values of cosecant or secant or cotangent. But I know what? Cosecant is 1 over sine of theta. So that means 1 over sine of theta is plus or minus the square root of 2 over 1. So if I flip both sides, I get what? I get sine of theta on the left side is equal to, well, when I flip this, plus or minus 1 over the square root of 2. And if I rationalize this, this is the same as what? Plus or minus root 2 over 2. So this is why you got to be a little bit decent at rationalizing so you can solve these problems. All right, now that number looks familiar to me. So let me go to my unit circle. First, where is sine positive root 2 over 2? Well, that's pi over 4 and 3 pi over 4. And where is sine equal to negative root 2 over 2? That's 5 pi over 4 and 7 pi over 4. So those would be your 4 answers for that trig equation. So several steps there. Solve for the trig function, take the square root so it's plus or minus, but then we don't know cosecant, or at least I don't, maybe you do, so you can maybe skip that step. But instead, I'm going to write cosecant using my trig ratio. It's 1 over sine, and then flip both signs and rationalize, and now I have a number that I'm used to seeing on my unit circle. All right, so that's the third one. The fourth problem. So now we're going to get a little more tricky. So hopefully you didn't find those to be too tricky. Kind of straightforward what you have to do. They were more or less like simple quadratic or linear types of equations. But what if I have the following? 2 cosine squared theta minus cosine of theta minus 1 is 0. Yeah, sorry, George, no idea. I'm just gonna have to lose the points on my final exam. Well, why would you want to do that? You can do these. I have faith in you guys. You need to have faith in yourself if you need to. So this is confusing with the cosine function. So let's do substitution. So I'm going to say x is equal to cosine of theta. So if I rewrite this guy, it's what? It's 2 cosine squared theta, which would be what? X squared, minus cosine of theta, which I'm calling x, minus 1 is 0. Can you do this one? I hope so. So we can factor this one, and most of these will factor to where you can use zero property rule. So you have 2x and x, 1 and 1. Because I want the minus inside there, I get minus and plus. Now solve it like you would a regular quadratic, do zero property rule. So 2x plus 1 is 0, x minus 1 is 0. So 2x is minus 1, x is equal to negative half. And then here, x is equal to positive 1. We're not done, right? Because we did not start with x, we started with cosine of theta. So I have to put that back. So this one here, x equals negative half, really means cosine of theta is negative half. And x equals 1 really means cosine of theta is positive 1. So now, where on the entire unit circle between 0 and 2 pi, but not including 2 pi, is cosine equal to negative half? Well, that's when theta is 2 pi over 3, and theta is equal to 4 pi over 3. And then here, now this is the other issue that comes up a lot with you guys. Well, maybe not you guys, but students of the past. When you start trying to come up with these answers, a lot of the students, I don't know why, but a lot of the students forget all about zero. They start at 0, but they don't include it in their solutions, and they start looking around the unit circle. Oh, okay, where's cosine equal to 1? Oh, it's at 2 pi. Yeah, but you forgot the very starting point, 0. And not only that, we can't include 2 pi. Because remember, this was on the interval 0 to 2 pi. So 0 is included, 2 pi is not. So this would be what? Theta is equal to 0 radians. And again, these answers are all in radians in case you haven't figured that out yet. But so that's our solution for that equation. And last but not least, I have 2 sine squared theta plus cosine of theta is equal to 1. Well, what did I tell you guys? Like, you want to try to factor these like we did with the last problem. Maybe use zero property rule if we can. Use quadratic formula if we can. But for us to be able to do any of that, we need what? We need to have the same quote unquote variable, or in this case, the same function. And so I don't have that, right? One term has a sine function, the other has cosine. So how can I get around this? Well, what did I tell you guys? And not only that, so let's say that you're doing this at home and you skip the content video because it's like, yeah, I'm tired of watching George's content videos. Let me just get right to the examples and see if I can figure it out. That's fine. If we go back to lesson 2, when you guys were given the Pythagorean identities and you were given the Holy Grail identity, and I told you, you should also think of this as the what? The I'm stuck identity. Because as you move through the rest of the semester, if you find yourself saying, man, I'm stuck, I just don't know what to do here, try the Holy Grail. Will that get you out of trouble? And so let's say this was on a test, this problem. and you're like, oh man, the trig equations. I knew this was going to be trouble. Ah, geez, I'm stuck. I don't know what to do. Well, that's a good thing, right? Because when you're stuck, does the Holy Grail help you out? And it does in this case, because sine squared, I can rewrite as what? 1 minus cosine squared, right? That's my Pythagorean identity, the Holy Grail. So if I substitute this, I really have 2 times 1 minus cosine squared theta plus cosine of theta. And I'm going to minus 1 from both sides so that I can set this thing equal to 0, because ideally I'll have to factor and use zero property rule here in a minute. Now, so is everybody clear on that? Hopefully. We're just substituting sine squared with our Holy Grail, which is 1 minus cosine squared. Hopefully from like the proofs and the simplifies, that kind of stuck in your head there. Now distribute the 2. So 2 minus 2 cosine squared theta plus cosine theta minus 1 is 0. So I combine my like terms. I get negative 2 cosine squared theta plus cosine theta. 2 minus 1 is 1. So I get this. And this is pretty challenging to factor because of this minus in front here. So to get rid of that, I'm going to multiply the entire equation by negative 1. So this becomes 2 cosine squared theta minus cosine theta minus 1 is 0, which is the same problem we just got done doing, right? So 2 cosine squared minus cosine theta minus 1 is 0. So 2 cosine squared theta minus cosine theta minus 1 is 0. So then the rest, we just solve it the same way, right? So we're going to get the same answer. So 2 cosine theta, if you don't want to use substitution, 1 and 1 minus plus dot theta is equal to, what were our answers? 2 pi over 3, 4 pi over 3, and 0, and 0 radians. So again, the rest of this, solving it, is just like the number 4 that we did, because we got the same equation there. But that's how we get to the same equation. We had to do substitution using the Holy Grail, and then simplifying from there. So that's it. Hopefully that is enough examples for you guys to kind of get a general idea. Again, I mean, I could make this video like an hour and a half long and still not cover every type of trig equation that you're going to have to do. But all the techniques we just did with all of these equations, you should be able to transfer that over to the ones in the mastery set. And then, of course, the in-class assignments. And I would stress again, like if you have the time, do all of the problems in the mastery set just to get that extra practice. Because I'm telling you, the more of these you do, they all start to look the same. Like, oh, okay, substitute the Holy Grail, combine like terms, factor it, where on the unit circle. Okay, now I'm done. It's all going to kind of have that same feel to it by the end. So that's it. I'll let you guys tackle those problem sets, and we'll see you in lesson 13.